Hello guys and welcome. We'll start a series of lectures on penetration testing and server exploitation. Taking your first steps with penetration testing can be difficult. I assume you don't want to conduct your first penetration test on your production network. This can be really dangerous. The recommendation is to set up a testing lab environment, and this is where Metasploitable comes into play. Metasploitable is a Linux virtual machine that contains several intentional vulnerabilities for you to exploit. Metasploitable is essentially a penetration testing lab in a box, available as a VMware or VirtualBox VM. This VM can be used to conduct security trainings, test security tools, and practice common penetration testing techniques. Metasploitable is created by the Rapid7 Metasploit team. You can download it from rapid7.com or from sourceforge.net. If you download it from rapid7.com, you have to first create a free account. A company email address is required, but you can use a random email address if you don't have one. It doesn't have to be confirmed. Or you can choose to download it from sourceforge.net and no account is required. I've already downloaded Metasploitable. It comes as a zip file, so after downloading it, unzip the file to see its contents. This is its contents. In this video, I'll use VirtualBox, but you can use VMware as well. So in VirtualBox, I'll create a new VM. Its name will be Metasploitable2. Its type will be Linux. And the version, other Linux, 64-bit. And I'm clicking on Next. The memory size will be 1024 megabytes. Next, and I'll use an existing virtual hard disk drive. This is the metasploitable.vmdk file I've just unzipped. So add, I'm going to my desktop. That's the directory where I have unzipped Metasploit, and I'm selecting metasploitable.vmdk and open. And finally, I'm clicking on choose and create. Okay, it's done. Let's start the VM. Metasploitable is starting. The Metasploitable Linux operating system has started, and I'll log in using the default username, which is msfadmin. msfadmin. And the password is the same, msfadmin. Okay, sorry, I've written the incorrect password. If you want to become root or execute commands as root using sudo, you use the same password, which is msfadmin. For example, I'm becoming root, sudo su, and the password will be msfadmin. And I'm root. This is an intentional vulnerable VM, and you should never expose it to an untrusted network. It can be easily hacked. In VirtualBox or VMware, use net or host-only mode. In the next lectures, I'll use Kali Linux as the machine that will conduct the pen test or run the exploits, and Metasploitable will be the victim machine. So in VirtualBox, I'm gonna create a network for these two VMs, Kali and Metasploitable. So I'm going to Tools, Preferences, Network, and then add new net network. Okay, I have added a new net network. All options remain at their default values. And OK. Then I'll select Metasploitable and Kali and connect them to the newly created net network. So Metasploitable, Settings, Network, Net Network, and the name is Net Network. And OK. And the same for Kali Linux. The net network includes its own DHCP server, so you have to request a new IP address or restart the VM. I'm going to restart the VMs. And I'm restarting Kali as well. I want to check the connection between Kali and Metasploitable. I'm logging into Kali and I want to check its IP address. And its IP address is 10.0.2.6. Let's check the IP address of Metasploitable. MSF admin and MSF admin. Okay, they are in the same network. And I'm pinging Kali. It's working. And from Kali, Metasploitable. Perfect. The penetration testing environment was set up. We'll take a short break, and in the next lecture, we'll continue with Metasploit. Now, we'll start talking about the Metasploit framework, which is an open source penetration testing and development platform programmed in Ruby that provides exploits for a variety of applications and operating systems. Metasploit is one of the most commonly used penetration testing tools in the world. This exploitation framework consists of a group of tools and utilities put together to conduct security audits, test security vulnerabilities, enumerate networks, and evade detection or hack systems. It can be used by both white and black hat hackers because Metasploit is launching real, not simulated attacks. In this lecture, I'll show you how to start and update the Metasploit framework. If you are using Kali Linux, and I advise you to use it, Metasploit is part of Kali. We started by simply executing MSF cancel in a terminal. MSF cancel is the most popular interface to the Metasploit framework. It provides an all-in-one centralized cancel and allows you efficient access to virtually all the options available in the Metasploit framework. Let's launch it. It has started successfully. Let's move on and see how to update Metasploit. This is especially important because the Metasploit team is continuously releasing improvements and exploits for new vulnerabilities. As you can see, this is Metasploit cancel version 6.1.27 and there are 2,196 exploits available. Until recently, we could simply update Metasploit to the latest version by executing MSF update. I'm running MSF update. But, as you can see, Metasploit now responds that the command is no longer supported when Metasploit is part of an operating system such as Kali. And to update it, we need to use the apt package manager. So, to update it, I'm running sudo apt update && sudo apt install Metasploit framework. And the password is Kali. By the way, apt install is installing or updating the package to its latest version. I'm typing Y. It's downloading and installing the latest version of Metasploit. It was updated and I'm starting MSF cancel again. In the other terminal, I'm exiting the previous Metasploit cancel and I'm starting it again. This is the latest version of Metasploit, which is version 6.1.39. Let's go straight into Metasploit and see how to use it. I'll show you a real exploit on a vulnerable server. The hacker's machine will be Kali Linux and the victim's machine, the Metasploitable VM, the one we've installed and set up in a previous lecture. These two machines are connected to the same NAT network and we can check the network connection using ping. I'm logging into Metasploitable. And I'm running ifconfig on both VMs to see their IP addresses. This is 10.0.2.7 and this is 10.0.2.15. So ping 10.0.2.7 and it's working. And I'm pinging Kali as well. Great. In this lecture, I'll show you how a hack is performed from the beginning. The first step of an attack is called reconnaissance, which means collecting and discovering information about a system. So let's scan the target for vulnerabilities using Nmap, which is probably the most well-known network scanner. On Kali, I'm running as root Nmap -A and the target's IP address. And the scan is done. Metasploitable has some intentional vulnerabilities. In a real case scenario, hackers will do the same. They will scan for vulnerabilities, and if there are any, they will try to exploit those vulnerabilities. The Nmap report shows important information about the services that are running, their version and vulnerabilities. And we see there are lots of vulnerabilities. Let's take the SSH server and search on Google for exploits for that version. And we notice there are some exploits available. Those exploits can be executed using Metasploit. Let's focus on VS FTPD version 2.3.4, which seems vulnerable. This vulnerability will provide us with a root shell using a backdoor command execution. This means we'll have full root access to the vulnerable system. We can see information about the exploit. Now back to Metasploit, I'm starting the cancel by running MSF cancel. It's starting. Once started, we can search for a vulnerability or for a service by name. I'm running search vs FTPD. And it has found an available exploit for vs FTPD, and to run it, we have to select the exploit. I'm running use and the path to that exploit. So exploit Unix FTP and vs FTPD 234 backdoor. I'm hitting enter. The exploit was selected, and the next step is to check the options required to run it. I'm running show options. We notice there are two options available, rhosts and rport. Rhosts is the target's or the victim's IP address. In this example, it will be the IP address of the Metasploitable VM. So set rhosts and the victim's IP address 10.0.2.7. The other option, rport, is the remote port on which FSTPD listens. The final step is to run the exploit. Run. It found a shell, opened a session, and the target was hacked. We have gained access to Metasploitable VM remotely. A shell has opened and allows us to fully control the machine. We own that machine and we are connected to it as root. I'm running some commands on Metasploitable, the hacked machine. You see here, this is its IP address. These commands are run on Metasploitable. I'm creating a file on the hacked machine. Okay, I've shown you how a system gets compromised. We've intentionally used a vulnerable machine in a lab environment, but the same could happen in a real-world scenario. We are taking a short break, and in the next lecture, we'll go over how to use MSF Cancel. Modules are the core components of the Metasploit framework. A module is a piece of software that can perform a specific action, such as scanning or exploiting a target. Each task that you perform using Metasploit is defined within a module. To access the Metasploit framework, you need an interface. MSF Cancel is the most popular interface to the Metasploit framework. It provides an all-in-one centralized cancel and allows you efficient access to virtually all the options available in Metasploit. By the way, MSF Cancel may seem intimidating at first, but once you learn the syntax, you'll appreciate its power. Let's see how to use it efficiently. To see a summary of its usage option, execute MSF Cancel -H. These are its options. And to start it, just execute MSF Cancel at a terminal. Once in MSF Cancel, we can run Linux commands like in a normal shell. For example, if we want to check the network connection to the target, it's not necessary to open a new terminal because we can ping it from here. Let's check again its IP address, the Metasploitable's IP address. And from within MSF console, I'm running ping -c2. I'm sending only to ping pacx and the IP address. Great. The Metasploit console is designed to be fast and easy to use, and one of its most useful features is tab completion. There are lakhs of Metasploit modules available, and it can be difficult to remember the exact name and path of the particular module you want to use. As in the bash shell, entering what you know and pressing tab twice will present you with a list of options available or will autocomplete the string if there's only one option. For example, use E and double tabs. X completing the path. Let's go ahead and talk about the MSF console commands. To display a list of all available commands along with a description of what they are used for, type help or a question mark and hit enter. Let's take a look at some important commands. There are hundreds of modules and commands available. Once again, a module is a piece of software that can perform a specific action, such as scanning or exploiting. Each task that you can perform using Metasploit is defined within a module. Keep this in mind. To view a list of the exploits that are available, execute show exploits. If you have a general idea of what you are looking for, you can search for it via the search command. The search command will locate the string you are searching for within the module names, descriptions, or references. Search SSH. Search Windows. Search Windows. Search Android. These payloads, exploits, or auxiliaries are all related to Android devices. You can further narrow your search results by using other keywords or subcommands. Let's see the help for search. For example, I'm searching for Windows exploits related to SQL. Search platform :Windows, name :SQL, and type :exploit. All of these are exploits related to SQL that runs on Windows. Platform narrows down the search to modules that affect a specific platform, and type lets us filter by module type. There are more module types such as exploit, payload, evasion, encoder, or auxiliary. To dive deeper into an exploit, you can use the info command. It will provide you with detailed information about a particular module, including all options, targets, and other information. For example, info, exploit, Windows, Postgre, and Postgre payload. And you see here detailed information about that particular exploit. Now pay attention. My advice is to always read the module help before using it, because not doing so could have bad results. You could simply break a running system. Metasploit is not just simulating the exploit, but it's actually running it. And remember, not all Metasploit modules are included in Metasploit's update, but only those developed and approved by Rapid7, the company that develops Metasploit. If you have developed a new module or found one on GitHub, you will need to add it manually. Alright, that was an overview of MSF console. In the next lecture, we'll see how to use modules and what is the common Metasploit workflow. I'll see you right away. In this lecture, we'll see what is the common Metasploit workflow. The first step is to discover the target and the vulnerable services that are running. There are lots of vulnerability scanners, but most of the time, Nmap is the tool of choice. From Kali Linux, as root, I'm scanning the exploitable VM using Nmap and the -A option, which enables OS and version detection, script scanning, and traceroute. Nmap is scanning Metasploitable. And there are many vulnerabilities because this VM was especially designed for penetration and exploitation testing. In a real case scenario, hackers will do the same. They will scan for vulnerabilities, and if there are any, they will try to exploit those vulnerabilities. Let's take a look at this one. On port 6667, IRCD is listening. A hacker would search for exploits for that service and version on Google or on specific forums. And the first result takes us to the Rapid7 website, and we can see that there's a backdoor command execution available for that service. This version contains a backdoor that went unnoticed for months. By the way, Rapid7 is the company that develops Metasploit. And if we scroll down, we notice that there's also a Metasploit module that exploits the vulnerability. They even show us how to use it. Let's return to Kali and start Metasploit. I'm running MSF cancel. Once it has started, I'm searching for IRCD. So search IRCD. And there's one module available. To find more information about it, execute info and xname with the full path. So info, exploit, Unix, IRC, Unreal, IRCD, backdoor. To select a specific module, type use and the full path to the module. And if you want to go back or to exit the module, execute back. The next step is to see what are the options of the module. Show options. rhost comes from remote host and is the target IP address. I'm setting it. Set rhost and the target's IP address 10.0.2.7, the IP address of Metasploitable. Next, we'll have to select a payload. A payload is a piece of code to be executed through the exploit. It's in fact what to do after the target is exploited. To see all compatible payloads for this exploit, run show payloads. Most of the time, a hacker would like to get a shell to the hacked machine so that he can further install malware, run other commands, or consolidate his position on the machine or on the network. I'm setting a reverse shell as payload. So set payload and the path to the payload. Payload, cmd, Unix, reverse. This one. After setting the payload, you can further check what are the payload's available options. I'm running show options again. And there are two options for the payload: lhost and lport. Lhost is the local listening address, and I'm setting it to the IP address of Metasploit. So set lhost and the IP address of Metasploit. Let's see its IP address again. Remember that you can run shell commands directly in MSF console. And I'm running the exploit. The exploit is running and the machine was hacked. I'm logged in as root and I can execute any command in a reverse shell. A session was opened. I'm on Metasploitable, on the hacked machine. Take a look here. This is the IP address of Metasploitable. The command was run on the hacked machine. On this machine. I'm logged in as root. Now, we are in the phase of the attack called post-exploitation. It refers to any action taken after a session is opened. A session is an open shell from successful exploitation, like in this case. After successfully hacking the target, the attacker will be asking himself what to do next. In general, he wants to gain further access to the target's internal network or to cover his tracks as he progresses from system to system. Or maybe he wants to set up a backdoor to maintain more permanent system access. In this example, if the victim machine is restarted, the access will be lost. Of course, the hacker could run the exploit again, but the admin could patch or uninstall the vulnerable service. So, utilizing these techniques will ensure that some level of access is maintained, and that's why post-exploitation is so important. Okay, thank you, that's all. In this lecture, I'll show you how to hack routers and other embedded devices like IP cameras using Routersploit. The Routersploit framework is an open source exploitation framework written in Python and dedicated to embedded devices. It scans devices on your network to see if there is any vulnerability to a known exploit. For example, the VPN filter malware is such an exploit designed to infect routers, and it's estimated to have infected hundreds of thousands of routers worldwide. Such an exploit can be easily turned into a module and launched using Routersploit. The solution to such a vulnerability is in most cases a firmware upgrade. But how often do you check if there is any new firmware available for your router or your security cameras? I suppose that never, or not too often anyway. Most people set up routers and forget about them. They don't change the default password, update the firmware, or protect them in any way. Such a vulnerability is like a monster sleeping in your room and waiting to be woken by someone interested in finding it. Let's move on and see what are the components of Routersploit. Routersploit consists of various modules that aids penetration testing operations. Exploits are modules that take advantage of identified vulnerabilities. It's similar to Metasploit. Creds are modules designed to test credentials against network services. Scanners are modules that check if a target is vulnerable to any exploit. Then comes the payloads, which are modules that are responsible for generating payloads for various architectures and injection points. And generic are modules that perform generic attacks. Before showing you how to scan routers and other embedded devices for vulnerabilities, I want to start with a legal disclaimer. You are allowed to use Routersploit only on your own devices or on devices for which you've got permission. Let's get started and see how to install and use Routersploit. If you are using Kali Linux, you can install it automatically using apt because it's in the official repositories. I'm searching for Routersploit. apt search Routersploit. And it found the package. However, I'm gonna install it manually from the official website because I want to stay up to date. The installation is simple and I will just follow the official installation guide. First, I'm installing Python pip. The next step is to clone the GitHub repository. Then I'll cd into Routersploit directory and install the requirements. I'm copying and then pasting this line. I'm moving to Routersploit directory and here I'm pasting the line. It's installing some requirements. Perfect, Routersploit has been installed. In this directory, there is a Python file called rsf.py. This is Routersploit. I am starting it, Python 3, and the name of that file, rsf.py. Note that you have to be in the Routersploit directory. The Routersploit framework has opened up and you see that the interface and style are similar to that of Metasploit. A command line interface is available and you can see everything Routersploit has to offer by typing show all. We see the modules. As you can see in the output, there are a lot of exploits, default credentials, and scanners. If you want to search for a specific exploit or for exploits for a specific vendor, you use the search command. For example, I'm searching for anything related to Cisco. Search Cisco. I've got exploits for Cisco routers, cameras, or modules for finding the credentials. Or I could search only for exploits like this. Search type equals exploits. It's showing us only the exploits. Or I could search for anything related to cameras. Search device equals cameras. Okay, this is how you use Routersploit. You type exit when you want to close Routersploit. There's also the possibility to automatically update Routersploit modules, and I'd recommend you to do so since according to the Routersploit website, the project is under heavy development and the new modules are shipped almost every day. To update Routersploit, run git pull in the Routersploit directory. Git pull. It's already up to date. I've just installed it. At the end of this lecture, I want to introduce you to a new term called flytrap. A flytrap is a router that has been compromised and updated with a special firmware that prevents the user from updating or modifying the new firmware. Cherry Blossom is an exploitation framework that can transform vulnerable Wi-Fi routers into flytraps. They are advanced remote spying devices capable of being controlled from anywhere. Okay, we'll take a short break and we'll see after that how to exploit the default gateway using Routersploit. In the last lecture, we've seen what Routersploit is, how to install and start it. Now it's time to show you a real exploit on a router, and I'll choose the default gateway of the LAN. The first step is to find the IP address of the default gateway, which is usually the first or the last IP of the subnet. However, we could scan the network using Nmap or NetDiscover. In this example, this is the default gateway, 192.168.0.1. And I'm starting Routersploit. In the Routersploit directory, in this one, I'm executing Python 3 rsf.py. Let's start a module called AutoPawn used to scan for vulnerabilities. The style of working is the following: to select a module, type use, and then whatever module you want to use. Show options to display the parameters of the module you've selected. Set to set any of the parameters you see in the output of show options, and finally run to execute the module. Use tab key multiple times for completion. So I'm selecting the AutoPawn module. Use scanners AutoPawn. Use the tab key for auto-completion. Now to see the options of the module, I execute show options. These are all available options. We notice the target option, which is the most important. Let's set the target as being the default gateway. Set target and the IP address of the default gateway. The next step is to type run, and it will run all the known exploits against the target to see if it's vulnerable to any of them. It's checking for vulnerabilities. We are waiting for it to finish scanning. It takes some time, a minute or two, so I'm gonna pause the recording. And it's over. If there is no known vulnerability discovered, that's good news. Get to the next device and eventually repeat the scan after a while. Keep in mind that there could be other devices on your LAN that are not router and are vulnerable. My advice is to scan all IoT devices using Routersploit. You first discover all possible targets like IP cameras using Nmap, and then you run Routersploit against the targets. In our case, the router is vulnerable to this exploit. Routersploit displays the vulnerabilities, and I'm gonna select the exploit. If you want to see all available exploits, you type use exploits and then 2 times the tab key. And these are the categories. These are all routers exploits and all exploits for TP-Link, and so on. I'm selecting the exploit in order to execute it. To see all options of the exploit, you execute show options. The next step is to set the target. Set target and its IP address. And I'm running it. Perfect. Now let's see the payloads of the exploit. A payload is a customized piece of code that the attacker will execute on the vulnerable system in order to compromise it. So show payloads. A reverse shell is such a payload in which the attacker gains interactive shell access. the target machine initializes a connection to the hacker's machine, and the hacker's machine listens for the incoming connections on a specific port. We notice there are two payloads available. Let's select the reverse shell payload. It will send us a reverse shell. Set payload and the payload. The next step is to set the IP address of the local machine, the one that will receive the shell of the victim. This is our own IP address. This is the IP address. Set lhost and the IP address. The next step is to effectively run the exploit or fire the payload against the victim. To run the exploit with the selected payload, you type and execute run. I won't do it because I don't really want to break the router or anything else with this example. The conclusion of this lecture is that if you have a router or an Internet of Things device, it is your responsibility to make sure that it runs the latest version of firmware and that the default credentials have been changed. You can discover known vulnerabilities running Routersploit against the device and then mitigate the possible attacks. Also take a look at Repost, which is a Routersploit fork. It adds some nice features like wrapping your own applications inside a tailored interactive shell. Hello guys! In this video, I'll show you a very interesting attack of type denial of service called ForkBomb or Rabbit virus. Pay special attention to it because it can be executed by a non-privileged user and can bring down and make unusable the entire Linux system. I can honestly say that it was a very unpleasant surprise for me to test it on many Linux distributions and see that it works on all of them. In a matter of seconds and with only one line of code, a normal user will hack the system. Let's get started and see the attack live, but please don't test it on a production system because it will make it unusable. Run it in a VM or on a test system to which you have physical access. Be prepared for a crash and a forced reboot of your system. On the latest version of Ubuntu, as a non-privileged user, and this is the key here, I'm creating a new bash script. And inside the script, I'm adding a single line of code. $0 ampersand ampersand $0 ampersand. And that's all. Don't worry, I'll explain it to you in detail later. Now I'm saving the file, setting the execution permission, and running the script as usual. In a few seconds, the system will become unusable. I cannot even move the mouse anymore, and there's no chance to stop it. I try to run the ls command, but it doesn't work. The system has crashed. The script has caused resource starvation, crashing the system. The only way to get out of this is force reboot the system using the power off or reboot button. I'm stopping the VM and then starting it again so I can regain access. I'm pausing the recording until it starts so I can log in. The system has restarted. Let's take a deeper look at the script and what has happened. This is the script. It performs a denial of service attack that makes use of the fork system call to create an infinite number of processes. So, $0 is a special variable that represents the script itself. So the script is running itself recursively 2 times and then is going in the background for another recursive call. It does this indefinitely. Ampersand at the end puts the process in the background so new child processes cannot die at all and start eating the system resources. Let's see how to prevent such a fork bomb. If you run ulimit -u, you'll see the number of available processes for the current user. This value is very large. You can also run ulimit -a to see a lot of limits available to the shell and the processes it creates. To prevent the fork bomb, we'll lower the number of processes the user can start. The processes cannot continuously replicate themselves. As root, I'm opening the following file: /etc security limix.conf. And at the end, I'm adding the following line: the name of the user, student, hard, and proc, and the value, for example, 2000. This will limit the user processes to 2000. Please don't set too low the ulimit numbers. By doing so, you will prevent the user from working on the system. And you can also add such a limit for a group as follows: add the name of the group, for example, admins, hard, and proc, and the value, for example, 4000. I'm saving the file. The new limits will be available for new sessions, so I'm logging out and then logging in again. I'm opening a shell and running the script again. We see that the system is not becoming unavailable and we can work on it. See this message, which practically means that the shell is not allowed to create new processes. But the system is not unusable. I can work on it. Congratulations, you've just mitigated the fork bomb attack on Linux and made your system more secure. A rootkit is a collection of malicious computer software designed to enable access to a computer that is not otherwise allowed. A rootkit contains malware that can steal data and take over a system for malicious purposes, all while remaining undetected. Typically, a hacker installs the rootkit after having obtained privileged access to the system. Obtaining this access is a result of a direct attack on the system, such as exploiting a known vulnerability or getting a valid password obtained by cracking or social engineering tactics like phishing. Once the rootkit is installed, it becomes possible to hide the intrusion as well as to maintain privileged access. A rootkit can hide a keylogger, capturing your keystrokes and sending your confidential information to its master who controls it. It can also allow hackers to use your computer for illicit activities such as launching a denial of service attack against other computers or sending out spam. Rootkit detection is difficult because a rootkit may be able to subvert the software that is intended to find it. Rootkits could remain in place for a very long time because their role is to hide any trail of their existence. So finding rootkits is a challenge, especially if it loads kernel modules and compromises the kernel. By modifying kernel system calls, kernel rootkits can hide files, directories, processes, or network connections without modifying any system binaries. I want you to remember something very important. If the system was compromised by a rootkit and you find out about it by any means, you must reinstall the entire system. Never, but never trust a compromised machine, period. Now that you know how dangerous a rootkit can be, let's go ahead and see how we can scan for rootkits and malware on a Linux system. We'll take a look at two security tools, Rootkit Hunter and Check Rootkit. It's recommended to run these tools from a rescue disk, typically a live one, or optionally, they can use an alternate directory from which to run all their own commands. This way allows the rootkit scanner to trust the commands upon which they depend a bit more. Rootkit Hunter, or RK Hunter, is a security monitoring tool for Linux which scans for rootkits and other possible vulnerabilities. It does so by searching for the default directories of rootkits, misconfigured permissions, hidden files, kernel modules containing suspicious strings, and comparing hashes of important files with known good ones. It is written in Bash, so it's portable and can be run on any Linux-based systems. Let's install RK Hunter from the official Ubuntu repositories. apt install RK Hunter. It's installing it. After installing RK Hunter and prior to running it for the first time, update the file properties database. One of the checks RK Hunter performs is to compare various current file properties of various commands against those it has previously stored. I'm running RK Hunter --prop upd. This command causes RK Hunter to update its data file of stored values with the current values. Let's run a full system check. RK Hunter --check. This command performs various checks on the local system. The result of each test will be displayed at the terminal, and if anything suspicious is found, then a warning will be displayed. A log file of the tests and the results will be automatically created in /var/log. Let's take a look at the log file in another terminal. I'm splitting the terminal in two, and I'm connecting to the VPS again. This is a new connection to the same server. So tail -f /varlog rkhunter.log. And we see there a lot of information. All the tasks it performs. I'm pressing enter to continue. I'm waiting for it to finish. And it's done. There's only one warning that says that SSH root access is allowed. If you want to print at console only the warnings, run it with the ---- report warnings only option, like this. Note that it still updates the log file along with all the checks it makes. Out of the box, Rootkit Hunter will throw up some false warnings during the file properties checks. This is because a few of the core utilities have been replaced by different scripts. For example, on this Ubuntu VM, RK Hunter reports this warning. I know this is a false positive since I've just installed the system from a trustworthy source. These warnings can be muted by whitelisting them in the RKHunter config file. Here, I'm writing script whitelist and the path to the binary that generated the warning. Let's take a look at another tool called CHK Rootkit that locally checks for rootkits. I'm installing it. apt install chk rootkit. And to start a scan, simply run as root chk rootkit. It's performing lots of tests, displaying the results on the screen. Note that a warning doesn't necessarily mean that the system was compromised. It's just a red flag that needs to be further investigated. The first thing you should do is search on Google for check rootkit and the warning it has displayed. We can also run it in quiet mode by using the -Q option, and it will print out only the warnings if there are any. And it's recommended to frequently run a cron job that scans for rootkits. That's all about rootkits and rootkit scanners. Thank you.